Okay, so so we will move to this, okay, learning outcome 3, okay. So there we have to describe some basic circuits and network concept, and we need to see how to analyze and also design problems, okay. So first we have to do the analyzing, okay. So as I told you, there are two ways to analyze microwave circuits, okay. One is using Maxwell equation, okay. Other one is using transmission line theories, okay. So when we are analyzing circuits, okay, microwave circuits, okay. So there are some special parameters. Some parameters are important, okay. We need to focus on some parameter, okay. So actually, we will move to this chapter 4, that is microwave network analysis, okay. So there are some introduction, maybe uh, you can read them if you have time, okay. So basically, here we are going to learn some parameters, okay. Some parameters, actually mainly 3 parameters, maybe, okay. That is impedance uh, parameter, admittance parameter, and scattering parameter, okay. And also ABCD parameter, actually 4 parameters, okay. There are 4 parameters we have to learn, okay. So these parameters are very important when we are analyzing uh, microwave circuit, okay. So first, if we move to this one, okay, so you know what is impedance, okay. Impedance and admittance you already know, okay. So impedance, normally impedance is a complex value, okay. So it has a real part, that is a resistance part, okay, and as well as a reactance part, okay. So this reactance part may be capacitive or may be inductive, okay. So there is a reactive part, okay. So this reactive part may be capacitive or may be inductive, okay. So if it is capacitive, it is minus, okay. So this impedance will be R minus value, and if it is inductive, it will be plus value, okay. So it is likewise, if it is capacitive reactance, so it will be like this, okay. Here the sign is minus, okay. And if it is inductive, it will be plus value. There, okay. So here the sign is plus, okay. Um, so that is impedance, okay. And admittance, admittance is the 1 over impedance. 1 over impedance is an admittance, normally denoted in Y, okay. So Z or impedance parameters are there, and all as well as Y parameter, that is admittance parameter, okay. Impedance and admittance parameter, okay. So we will focus on these 2 parameters first, okay. First, actually, we will focus on impedance parameter, okay. So normally, how we can get the impedance? So we know that by Ohm's law, V equal I Z, okay. So Z is V divided by I. This is impedance, no? This is how we define the impedance. This is the impedance, okay. Voltage divided by the current. So that is the impedance, okay. So if we consider any microwave component or microwave circuit, okay. Actually, this is not related with only micro, any circuit, okay. So if you consider any circuit or maybe any component. Okay. For example, if you consider the amplifier, if you consider the amplifier, consider amplifier. Okay. So uh, if you are given an input, if you are given an input, in, it will give a amplified output. Okay. So that is the function of an amplifier. If you give an input, it process the signal. So amplifier do it, amplifier do the amplification. Okay. So amplifier will amplify it and give output. Okay. So it has an input and it has output. It has an input connection, input port, and it has output port also. It has output port also. If you consider filter, if you consider filter, you have a input signal and also you have output signal. So input filters. So for example, let's say that this is a high pass filter. Okay. So if you send a frequency, okay, from low frequency to high frequency signal, F high to F low bandwidth, okay, specific bandwidth, maybe the low frequency will be cut off and only high frequency uh, will give as the output. Okay. So if you consider filter, it has one input port and another output port. Okay. It also has an input port and output port. Okay. Output port. If you consider analog to digital converter, you are giving analog signal and you will have a digital output. So it has an input port, output port. Okay. So this kind of component or circuits are normally known as two-port network or two-port circuits. Okay. So these are two-port circuits. These are two-port circuits. These are two-port circuits. Okay. Amplifier, analog to digital converter, digital to analog converter, filter. Okay. So these kind of component are rectifier. Rectifier. These kind of components are or circuits are two-port circuits, two-port network, two-port network. Okay, two-port network. And if you consider, okay, now tell me, if you consider oscillator, if you consider the oscillator, how many inputs are there and how many outputs are there? So how many ports are there? If you consider oscillator, how many ports? How many ports? Two pins, yes, two pins are there. It is like this, okay? Two pins are there. Two pins are there. Your answer is correct. Two pins are there. If you consider analog to digital, sorry, if you consider filter, how many pins are there? If you consider a filter or amplifier, let's get the amplifier. If you consider amplifier, how many pins are there? Hmm. Yes, three pins. What are the pins? What are the pins? Okay, Rangini. Okay. So it is like this. If you consider amplifier, okay, if you consider transistor amplifier, okay, you have, so let's say that this amplifier is like this, no? If you consider amplifier, okay, if you consider amplifier, okay, okay, so this is the collector, this is the base, and this is the emitter, okay. So if you consider common emitter amplifier, okay, common emitter amplifier, okay, this is the input side, this is the output side. Yeah, you are correct. You have three pins, one, two, and three pins are there. Okay. So you can see that this is the input pin. This is the input pin. Base is the input pin. Collector is the output pin. What is this? This is the ground pin. But this ground is relevant to this side, input side, and also this side, output side. Okay. So if you consider amplifier, okay, it has actually four pins. Normally it has four pins because here only ground is there. One ground is there, no? One ground is enough. Okay. This one and this one is grounded actually the same pin. Okay, but it has four pins normally. This is the input side, this is the output side. So it has four pins. Okay. Actually, this normally port means not pin. Port is not equal to pin. Okay, port means this is the port. This is the port. The total signal should be given to here. This is the port. This is the port. And this is input port. The signal one and grounded one. Ground terminal. And this is the output port. This one and ground terminal. Okay. So this is a two port. Two port. Although it has three pins, it has two port. It has two port. Okay, it has two port. Understand? Okay. Animal, can you see me? Can you see me? This is the amplifier. Can you see me? Yes, normally port has two pin. Normally port has a two pin. Ground pin and the signal pin. Okay. So I hope you can see me. Okay. So this is actually an amplifier. Okay, this is amplifier. Actually, we use this in optical communication. Okay, don't worry. This is a amplifier. Okay, actually, this amplifier is in microwave range, as I can remember. Maybe in uh, maybe not in microwave range. Okay, maybe higher range. I can't remember. Okay. Anyway, this is amplifier. This is amplifier. Okay. And this is the input. This side is the input. I will show this side. This side is the input and this is the output. Okay. So you are giving the signal here. Okay. You are giving the signal here. This is the port. This is the port. If you consider this port, the outer one is the ground one and the inner conductor, maybe you can see inner conductor, that is the signal. Okay. So altogether, this is a port. This is a port. Okay. So to give a signal, we should have a ground port. Okay. We should have a ground terminal. Otherwise, the signal will not propagate. Okay. Will not be propagated. Okay. So this is output port. If you consider output port, it also have a ground one, that outer part, and the uh, in inner conduct. Okay. So this is a port. Okay, this is a port. Now, if you consider this oscillator, okay, oscillator one pin is a ground pin. One pin is a ground pin, and other pin is a signal pin. Okay, so this is the ground pin and this is a signal. Okay, so you have to power up this oscillator. Okay, to power up also there are pins. To give the power, there are pins. Okay, but that power is only for its operation. It is not a signal, input signal. Okay, it is not an input signal. It is just a power power supply to operate it. Okay. No, it is active. Oscillator is active one. We are giving power means it is active component. If you no need to give power, it is a passive component. Okay. Some oscillators are passive actually. Okay. Some oscillators are passive crystal oscillators. Okay. So they are passive actually. Okay. But some oscillators are active. Okay. Okay. Anyway, if you want to give power, if we have to provide power, okay, so that is not considered as a port. It is a power port. If we need to give power, it is a power port. Okay, power port. So here we are not considering the power ports. Okay, we are not considering power ports. We are only considering signal ports. Okay, so how many signal port it has? Oscillator has how many signal port? Only one, no? Oscillator has only one. Okay, so it is a one port circuit or one port network. If you consider oscillator, it is one port device, one port circuit or one port network. Okay, so two ports networks are there, one ports networks are there. If you consider antenna, okay, if you consider antenna, how many ports are there in antenna? How many ports are there? Okay, tell me what are the ports? Tell me what are the ports? Hello? මම lecture එකේ ඉන්නේ. No, if you consider antenna, how many ports? This antenna, uh, if you consider antenna, how many ports are there? Yes. Okay. Actually, if you consider antenna, it doesn't have antenna. Okay. Wait a minute. Pandima, this is antenna, no? This is antenna. Okay. So if you consider this one, okay. So this is the antenna input port. Okay. So there are two pins actually. One is a ground one and other one is a signal one, middle conductor. Okay. So this is one port. This is this is one port and there is no other ports. No, only this one is there. Only this port is there. Okay. So antenna is a single port. Your answer is correct. Okay. Your answer is correct. It is a single port. Okay. Okay. It is a single port. So if you consider antenna, you have only one ports there. Okay. You have only one port. Okay. So that is also single port antenna. Single port device, single port network. Antenna is a single port network. Okay. Now you can see that two ports networks are there, one ports networks are there. Okay. So what about three ports network? Are there three ports network? Are there three ports network? Can you give an example for a three ports network? Can you give example? Transistor. Transistor is not three ports, no? Because you have, yeah, just a component. Tell me, is op-amp three ports? No, it is a two ports device. Op-amps also two port device. What is three ports device? Okay. Okay. Don't always don't think about the ports. Okay. Sorry, pins. Okay. Don't try to identify the port using pin. Okay. Uh, okay. Have you seen this one? So can you see how many ports are there? If you consider this device, how many ports are there? How many ports are there? Three. Yeah. This is a one pin. There are two pins. So there are one, two, three. Okay. Actually, if you consider, this is the input port. This is the input port, and these two are output ports. Okay, these two are output ports. This is a power splitter. This is a power splitter. Okay, so if you give a signal to input, input, okay, so it will split. This splitter will split the signal and send one portion here, another portion here. So this is a splitter. For example, if you give a sine signal here, let's say that amplitude is 2 volt. Okay, sine signal here, this power split. Okay, this is split power into, let's say that it is half to half. Okay, so half power is coming out here, half power is coming out here. So if you give a 2 volt signal, 2 volt sine signal, sinusoidal signal, what is the power of that sinusoidal signal? So maybe in signal and system, you have learned the power of a sinusoidal signal can be calculated using a square root 2. Okay, a square root 2. This is the power of a sinusoidal signal. So A is 2, sorry, A is square divided by 2. Okay, A is square divided by 2. Okay, so 2 is square, that means 4, that is 2 watt. Okay, so it is 2 watt power. Okay, so 1 watt power will out here. Okay, so 1 watt power is output here, 1 watt power is out here. Okay, so this is a 3-port network. If you consider this one, this is also 3-port network, but uh, this is not a splitter. This is called bias T. Okay, this is called bias T. Okay, I think maybe you have learned this kind of components. Okay, so this is the input. If you give the input here, you can get the DC filtered signal here, and you can get the, sorry, this is the input. Okay, this is the input. This side is the input. You are giving the input here. Okay, so this port you will get the AC signal. Okay, DC filtered one, because there is a capacitor here. Through the capacitor, the DC signals are not pass. Okay, DC signals are not passed. Okay, okay. So you will get the AC signal here. AC signal here or here, from here or here. Okay, and if you give a signal here, okay, and if you give a signal here, sorry, maybe here, no, from here. If you give a signal from here, okay, so this will pass. No, it is like this. Okay, if you give a signal here, if you give a signal here, sorry, I explained it wrongly. Okay, if you give a signal here, DC plus AC signal, okay, that means if you give a, for example, if you give a sinusoidal signal with a DC shift, okay, so that is a sine signal and DC signal combination. Okay, so if you give that kind of signal here, okay, so from here, this capacitor will pass only the AC signal. It will not pass the DC signal. Okay, so here you will get the 0 DC shifted signal. That means DC part is removed. Okay, and from here, that is, the inductor is there. So inductor will block the AC signal, and you will get the DC signal here. Okay, so if you give an input, if you give a DC plus AC signal, from this side you can get the AC one, the pure AC one. This side you can get the pure DC signal. Okay, so this is a bias. Okay, that is also true. Okay, and how many ports are here? If you consider this one, how many ports are here? So there are 4 ports. Maybe you can remember 1, 2, 3, 4. Okay, these are for power. Okay, these ports are for power. Sorry, this is a 5 port. Okay, these are 5 port. 1, 2, 3, 3, 4, 5. This is a 5 port. Okay. Uh, Actually, this is the RZ converter. Okay, RZ converter. Okay. Uh, but we no need to have the operation of it. Okay, but this is a 5-port network. You can see that this is a 5-port network. Okay, so now basically you should understand that there are networks with different number of ports. Okay, that is the idea you should get. Okay, okay, so very importantly, you should understand that there are some networks or circuit with 1 port, 2 port, 3 port, 4 port, 5 port, likewise. Okay. So there are some circuit with different number of ports. Okay. 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 So basically, if we consider a N-port circuit, okay, if you consider the N-port circuit, okay, generally, if you consider the N-port circuit, okay, if you consider N-port circuit, okay, so here one diagram is given, okay. So this is the circuit actually, this is the circuit. So this can be a coupler, this can be a combiner, okay. So anything, okay. For example, if you consider the rat race coupler, okay, we will design a rat race coupler, okay. We will design a rat race coupler, okay. So there are several ports. Number of ports can be there, okay. Number of ports can be there, 2, 3, 4, 5, 6, 7, 8, 9, like this, okay. So this is the circuit, okay. And these are the ports. These are the ports, okay. So you can see that there are here only 4 ports are there, okay. But this is considered as an in-port circuits, okay. So there are some circuits here from 4 to N, okay. Okay. So this is 4-port network, okay. And these are the voltage and currents, okay. So if you consider any port, okay, there is a input current and voltage as well as reflected or output current and voltage, okay. So this one is denoted the port, okay. This is the port number, this is the port number, and plus or minus will denote it will forwarded signal or reflected signal, okay. So there are two voltage and two currents we can uh, mention. We can uh, about which one you are talking, Randima? What ground? Uh, you means you are you are just uh, consider this one. If you consider this one, oh, yeah. So actually, the ground and lines are not mentioned here. Okay. So this may be a maybe this may be a ground and this may be a uh, uh, line. Okay. So it is not mentioned here. Actually, it is not much important. Okay. It is not much important. We are considering this port actually. Okay. It is like this. Okay. It is like this. If you consider this one, okay. So this is one port. This is one port. It has a ground and it has a pin. Okay. But this is a port. That is a port. We can input, we can input the signal or we can get the output signal. Okay. If we can input the signal or get the output signal, it is a port. Input or output port. Okay. So this is a port actually. This is a port. So if you are, for example, USB port is a port. Okay. So using the USB port, you can input the signal or get out the signal. Okay. So if you consider USB, okay. This is a USB port. Okay. So, so this is the port. Okay. So you can input the signal and you can output the signal. Okay. So normally when we are talking uh, about the port, we are not carrying the pins. Okay. This is a live pin. This is a ground pin. We no need to care. Okay. Did you get it? We consider the whole thing as a port. That's it. Okay. If you are input or output the signal, if you are connecting input or out, if you are connecting a signal or you are getting out a signal, that is a port. That's enough. Did you get it? Okay. So don't forget Ramnimal, okay? So you need to keep in mind those things. Okay? Otherwise, maybe when we are doing uh, questions, maybe you will get confused. Okay. Okay. Anyway, this is one port. This is a port one. Okay. This is port one. This is port one. This is port two. This is port three. This is port four. And there are some ports, and this is port in. Okay. So if you consider a port, there are input signals, forwarding signal, as well as reflecting signal. Okay. Signal means there are voltage or current forwarding, voltage and current reflecting. Okay. So if this is the input, so this letter emphasize the port number. Okay. So this is the notation. This is the general notation. Okay. So now, okay, now, uh, okay, now, um, okay, maybe actually these are transmission line. Okay, this is a microwave network. No, this is a microwave component. Okay, so we have to consider a port. Actually, this should be a this port is always related with the transmission line. Okay, so we are giving a signal. We are giving a signal through the transmission line, and we are getting out the signal through the transmission line. Okay, so if you consider that that for if you can remember that one, okay. Okay, so if you consider that one, for example, this one. Okay, so there is a transmission line. There is a transmission line section definitely. And also this connector. This connector is also a transmission line. This is a coaxial transmission line. This is a coaxial transmission line, okay? This is a connector, that's okay, okay? But this is a coaxial transmission line, no? Okay, because it has uh, outer conductor and it has an inner conductor. So this is a coaxial transmission line, okay? But this transmission line we used to have connection, okay? Okay, that transmission line, this transmission line section, this is actually a transmission line section, okay? Don't get confused. This is also, this is a connector, that is correct, but this is a transmission line section, okay? It has a outer conductor and it has a length, okay? This is a transmission line section. Okay. So this port, that is a connector related with the connector. Okay. Actually, that connector is nothing but the transmission line. Okay. That connector is a transmission line. This connector is a transmission line. This is a transmission line. Okay. This is transmission line. This is a transmission line. This is also a transmission line. This is a transmission line. Okay. So if you consider transmission line, okay, there are some forwarding signal and backwarding signal. So consider there are some voltage forwarding and voltage reversing. Okay. So if you want to calculate the total, that means the resultant voltage, that is nothing but V plus V minus. Okay. Forward plus reflection voltage. That is the algebraic sum of forward and reflection voltage. That is the voltage relevant to this port. This voltage can be an input voltage or output voltage, as well as current, that is a forwarding current and reflecting current. Okay. So total current will be the algebraic sum of the uh, current forwarding and current reflecting. Okay. So here, here, uh, here, so we are going to write the impedance. We are going to find the impedance. Okay. So if you consider V equal IR, V equal IZ, this is the impedance. Okay. So you need to write V. If you know V, if you know I, you can find the Z. Okay. Okay. So this voltages and the currents and the impedance values, okay, impedance values can be um, written using a matrix form. Okay, this is the matrix form. Okay, so we will see it. I will explain it. Okay, I will get the example. Okay, I will get the example. For example, let's take the uh, amplifier or something, two-port network. Two-port network. So this is one port. This is another port. Okay, this is another port. Let's say that this is input port and this is output port. Okay, output port. Input port, let's say that this is port 1 and this is port 2. Okay. So here you have input voltages, sorry, forwarded voltages, V plus, and for forwarded current, I plus. Okay. So this is this is uh, defined as port 1. Okay, so here we have V1 and here we have I1. Okay, and there are some reflected voltages and current also. So those are V1 minus I1 minus. Okay, and if you consider the output port, same are there, V2 plus I2 plus, because we define this port as 2. Okay, these are uh, these are forwarding. These are forwarding voltage, and and some reflected voltage are there. Reflected voltage are okay. Reflected voltage are V2 minus I2 minus. Okay. So there are four voltage and four current values. Okay. So this is port 1 and port 2. So how many impedance can we, how many number of impedance can we define here? Okay. So this is port 1 to port 2. So you can, sorry. So this is one port and this is another port. No, okay. So here we have a impedance and here we have a impedance. Okay. So this is port 1 to 1. Okay. So it is normally referred as Z1. And if you consider one, this is port 2 to 2 impedance. Okay. So there are another impedance 2 to 2. Okay. And also there is another impedance port 1 to port 2 impedance. Port 1 to port 2 impedance. That is Z1 2 impedance and port 2 to port 1 impedance. That is Z2 1 impedance. Okay. So you can define this kind of four this kind of four impedance value. Okay. So Z11 Z11 actually what is that? So you know that V equal IR. Okay. So here there is a total voltage here. Okay. There is a total voltage here V1 and total current here I1. What is V1 equal? V1 is equal to what? Kandiman? V1 is equal to what? No, no. If we write V1 using this one, so there are some forwarding and reflecting voltages and current. No? So if you write, yes, okay. So V1 is equal to actually V1 V1 plus value plus V1 minus. Okay. So that is yes. Yes, correct. Okay. V1 plus and V1 minus. Okay. And I1, what is I1? Okay, that is I1 plus and I1 minus. Okay. So V1, I1 is there. And if you consider this one, there is a V2 and I2 also there. So V2 can be written as V2 plus V2 minus I1, I2 can be written as I2 plus I2 minus. Okay. So there are input voltage and current. There is output voltage and current. Okay. So input voltage is Vi, output voltage is V2, input current is I1, output current is I2. Okay. So you can get this V1 and I1 that is related with port 1. You get port 1 voltage value, you get port 1 current value. Okay. Okay. So you will have V1 divided by I1. Okay. Actually, that is referred as Z11. Okay. So that is the Z1. Then how we write Z22? What is Z22? Z22 is equal to what? Yes, very good. So if you consider this port, okay. So here you have a V2 value and here you have I2 value. Okay. Now if you consider this one, V2 divided by I2. This is a impedance value, no? So that is the Z22 impedance. Okay. So this is referred as input impedance. This is referred as output impedance. Okay, this is referred as input impedance and this is referred as output input. Okay. Now there are two impedance you can calculate. That is uh, very very clear. Now, if you consider this voltage, if you consider port 1 voltage and port 2 current, okay? So port 1 voltage is V1, that is divided by port 2 current, I2. This is also impedance value, no? Because it is also impedance value. Voltage is divided by current. That is the impedance value. So here, we can calculate that one, V1 divided by I2. Okay, that is also impedance. What is that impedance? Yes, that is a impedance. So what is V2 divided? V1 divided by I2. That is the impedance from port 1 to port 2. Yes, that is Z1 2. That is Z1 2. Okay. In the same manner, if you consider port 2 and port 1 current, that is also impedance. So that is V2 divided by I1. That is also impedance. That is 2 to 1 impedance. He said 2 to 1. Yes. Okay. Okay. So using this voltages and current, we can define four impedance values. Four impedance values. We can calculate four impedance values. Okay. Okay. So we can write this equation, this as a matrix. Okay. There are two voltages value, V2, I2. There are two voltages value, V1, I1. These are the voltage value. Similarly, we don't know the matrix and there are two currents. This is V2, okay. V1, V2. There are two currents value, I1, I2. Okay. Okay. And so using this four current values, we can define four Z value, no? Four Z value. There are four Z value we can define. Okay. So if you consider two port, 2 into 2, that is 4. Value you can define. Okay. So there are four parameters. Okay. So this one is, okay. So this one is, okay. So this is a matrix, no? Okay. This is a matrix. Okay. So normally if you consider matrix, okay. If you consider matrix, normally this kind of matrix, okay. This kind of matrix, okay. So here some one here some one, okay. So normally this one entry is referred as N and M. Maybe you can remember. This N is stand for number, the pronoun. N is stand for pronoun. M is stand for column number. Yes, very good. Okay. This M is stand for column number. This is column. Okay. So this will be first row, first column, first row, first column. So it will be 1, 1. This will be first row 1, but second column 1, 2. This will be first row 1, third column 3. This will be first row 1, fourth column 4. And this will be second row 2, first column 1. This will be second row, second column. This will be second row, third column 3. This will be second column 2, fourth column 4. Okay. So this will be the number for row number, and this is the column number. So same way we can define this. Okay. So this is first row, first column. This is first row, second column. This is second row, first column, second row, second column. Okay. Yes. So you can define this matrix like this. Okay. And this matrix can be written in equation form. Okay. This can be written in equation forms also. Okay. So normally, okay, normally, okay, okay, this is can be written in equation form. Okay. So if you consider this first one, if you consider this row, okay, if you consider this row, so the voltage is V1 and equation is there, equation is there. So this will be Z1, Z1, okay, Z11, okay. Here you have to multiply the matrix, okay. So how we can multiply the matrix? Can you remember? Matrix multiplication, okay. So check matrix multiplication, okay. Matrix multiplication, okay. You can check matrix multiplication, okay. So normally to have a matrix multiplication, to do the matrix multiplication, uh, we have a matrix, okay. We have a matrix. Let's say that if you have a n column matrix, okay, in row matrix, you should have a n column matrix to multiply. Okay, otherwise that matrix cannot be multiplied. Okay, so normally number of column should be equal to number of rows. Okay, so otherwise we can't do the matrix multiplication. Okay. So normally matrix multiplication is doing, okay, when we are multiplying the matrix, okay. So uh, normally actually first we are considering the column matrix and other is, sorry, row and the column. First we are considering the rows, okay. So this is row 1 multiplied by column 1. Row 2 is multiplied by column 2. Row 3 is multiplied by column 3. Row 4 is multiplied by column 4. Okay. And if there is row 5, there should be 5 columns. Okay. Then we can multiply the each value. Okay. So that is the matrix multiplication. If I give you example, okay. If you have 5 matrix, let's say that A1, A2, A3, A4, okay. And so you can see that there are 1, 2, 3, 4 values, okay. So you should have 4 values here also. B1, B2, B3, B4, okay. So then this one is multiplied by this one, A1, B1 plus A2, B2 plus A3, B3, A3, B3 plus A4, B4, A4, B4. Okay. So here, so normally, actually it is like this. Okay. Maybe you can remember matrix multiplication check. Okay. So if you have n matrix, let's say that n by m matrix. Okay. And here you should have m by some matrix x. Okay. N by m, m by x. Okay. So resultant will be n by x. Your resultant matrix will be n by x. N by x. For example, if you have four matrix as I told you, A1, A2, A4. Okay. So this is one row, 1, 2, 3, 4 columns. 4 columns. 1, 2, 3, 4 columns. And here, this matrix should be 4 into any value. Okay, 4 into can be 1, it can be 2, it can be 3, any value. Let's say, let's take one value. Okay, so this will be B1, B2, B3, B4. This is 1 to 4, this should be 4 to 1. N to M, M to other value. Okay, M to any value, this can be any value. Okay, but this should be equal to this one. Otherwise, we can't do the matrix multiplication. Okay. Then the resultant matrix will be, so A1, B1 plus A2, B2 plus A3, B3 plus A4, B4. Okay. So you will have A1, B1 plus A2, B2 plus A3, B3 plus A4, B4. Okay. This is the matrix. Okay. So what is the dimension of this matrix? What is this is we called as matrix dimension. Number of rows and columns. So what is the dimension of this one? Yes, very good. That is 1 by 1. That is 1 by 1. 1 into 1. That is 1 by 1. Okay. You will have only one column and one row. That means that is a single value. That is a single value. Some single value. Okay. Very good. Okay. And if there are row 2, let's say that this is C1, C2, C3, C4. What will be the resultant matrix? Yes, it will be 1 into 2. 1 into 2. Okay. That means one row, 2 columns. One row, 2 columns. So first value will be this one. And the second value what? This A1 into C1, A2 into C2, A3 into C3, A4 into C4. That value. So it will be 1 by 2. Okay. So that is the matrix multiplication. Okay. So consider this one. This is 2 by 2 matrix. And this is 2 by 1 matrix. The matrix multiplication is possible, no? Here, the matrix multiplication is possible. So what will be the resultant? What? Yes, that will be 2 into 1. That will be 2 into 1. 2 into 1. This matrix. Okay. So normally, if you are considering this first row, V1 is equal to, you have to multiply this matrix, but only this first row. So Z11 I1, Z11 I1 plus Z12 I2, Z12 I2. Okay. So this is one equation. This is one equation. Another equation you can write as V2. Again, we have to do the multiplication here. Okay. So this is actually you have to consider this one and this one. Okay. So this is one matrix and this is another matrix. Okay, that way you have to consider. So Z21 I1 plus Z22 I2. This way you can write the equation. Okay. So this matrix form can be resolved into the equation form. It is like this. Okay. Okay. Um, Any problem up to here? Okay, now I will take three ports network. Now I will take three ports network. Okay, so we will have a three ports network. We will have a three port network. This is our three port network. Three port network. Okay. So this is one port. This is one port. There are another two ports. Okay. So let's say that this is port one, this is port two, this is port three. Let's say that total impedance, total voltage here is V1, total current is I1. Here V2, I2. Here V3, I2. Okay. So for this one, can you try to develop the impedance matrix? And we try to develop the impedance matrix. Okay. And I'll get 5 minutes and try to develop the matrix. Okay, you no need to type here, okay? Just write a paper and a pen. Just try to write this matrix, okay? So I will find it, then we can compare our equation, okay? Yes, there should be 8 elements. There should be 9 elements, no? There should be 9 elements, not 8. There should be 9 elements. 9 impedances. There should be 9 impedances. Let's see, just try. I'm not sure, okay? Just take 5 minutes and try. We will see. Yeah, there should be 9, okay? There should be 9. So try to develop the impedance matrix. Take 5 minutes. Randimal, okay? Okay. So we will try, okay? So, so you can see that there are three voltages, V1, V2, V3, three voltages, and three current, I1, I2, okay? And this will be our impedance matrix. This will be our impedance matrix, okay? So there are three columns now, three rows, okay? So there should be three rows, definitely. And also you need to do the matrix multiplication, okay? You need to do the matrix multiplication. Otherwise, you can't resolve this matrix, okay? So definitely you will have three rows, okay? Three rows, okay? Three rows, okay? And definitely you should have three columns. So three columns, three into one. So three into some, there should be some value, okay? Some row value, column value, and 3 to 1 matrix is there. Okay. So if you need to do the matrix multiplication, what is this number of column should be? That should be equal to number of rows, sorry, number of rows, yes, number of rows of this matrix. Okay. So that is 3. So this should also 3. So this should be 3 by 3 matrix. Okay. So there are 3 rows and 3 impedance. So it will be 3 by 3 matrix. That means there are 9 matrices at once. Okay. So this will be column 1, sorry, row 1, column 1, row 1, column 2, row 1, column 3, row 2, column 1, row 2, column 2, row 2, column 3, row 3, column 1, row 3, column 2, row 3, column 3. This is a matrix. Okay. Then how we can resolve this to equation form? Try to resolve this into equation form, Randima. Once you finish, so I hope your answer is correct. Is your answer correct? So try to resolve this into a equation form. Once you finish, just tell me yes, okay? No need to type. Okay, Randima, thank you. Let's see whether you got it, your answer. Ah, yeah. Okay, we will check. Okay. So, okay. So you need to consider first this row. This row. You need to consider this row. Okay. So that is, so the voltage is V1. V1 is equal to, so you need to do the matrix multiplication from this matrix and this matrix. This is 1 by 3 matrix. This is 3 by 1 matrix. This is 1 into 3. This is 3 into 1. So you can do the matrix multiplication. Z11 I1, Z11 I1 plus Z12 I2 plus Z13 I3. Okay. So this is first row. That is correct. Now we need to consider this row. That is V2 is equal to. So you need to do the matrix multiplication, this one and this one. So this is also 3 by 1 matrix. Sorry, 1 by 3 matrix. This is 3 by 1 matrix. So you will have Z21 I1 plus Z22 I2 plus Z23 I3. Okay. And if you consider this one with 3, that is Z. Now the matrix multiplication should do from here to here. Okay. So you will have Z31 I1 plus Z32 I2 plus Z33 I3. Okay. So there are three equations. Okay. So this is the equation form. Okay. Is this correct? Did you get this answer, anyone? Okay. So I hope you got it. Okay. And if you consider 4 by 4, 5 by 5, for a 4-port network, you will have 16 matrix, 16 Z value. For 5 ports, you will have 25. For 6, you will have 6 into 6, 36, likewise. Okay. Okay. So if you have input, how we can write this in general? Okay. That means you should have voltage value up to N, V1, V2, V3, up to N, Vn. No? If you have input, then here you should have N by N matrix. Here you should have N by N matrix. Okay. So that means Z11, Z12, Z13, likewise up to Z1N. Thank you, Bala. Then now, yes, N is square. Yes, N is square. This is equal to N square. Okay. So here this is row 2, Z21, Z22. Likewise, you will have Z2N. Okay. And like this, here you will have ZN1, ZN2. Likewise, you will have ZNN. Okay. So this is the matrix, and also you will have I1, I2, I3, likewise up to IA. Okay. So this is the matrix. Okay. So this is the impedance matrix. Okay. So maybe now you can understand how this come. Okay. So also this can be resolved into a equation form. Okay. Equation form. Okay. The similar way, we can define the admittance matrix also. Okay, so you know that admittance, when we are considering the admittance means 1 over Z. That is admission. Okay, so admittance will be I divided by V. This will be the admittance, I divided by V. Okay, so when you are finding the admittance, your first matrix should be current, I, then you have the admittance matrix, then you will have the voltage matrix. Okay, so admittance matrix will be look like this. Okay, I, Y, V. Okay, the same one, same way you can write the admittance uh, matrix also. Okay, now we will see what is this reciprocal and uh, lossless network. Okay, before that, okay, before that, so you now you can see that here two port network is given. Okay, two port network is given. Okay, and the impedance are given ZA, ZC, ZB. Impedance are given. Okay, so try to find the Z matrix of this circuit. Just get 5 minutes and try to find the Z matrix of this circuit. Okay, so you need to find the Z matrix. Okay, find the Z matrix. Find the Z parameters of the two-port network shown in figure 4.1. Okay, so they ask us to find the Z parameter. That means you have to find Z11, Z12. This is a two-port network. No? Okay, this is a two-port network. That means there are two voltage value and two current value. Okay, so here you will have two rows. Okay, as well as two columns. Okay, so Z11, Z12, Z21, Z22. Z12, Z21, Z22. There are four matrices you need to find. Okay. So try to find it. Okay. Maybe I will give you a help, Kandimal. Okay. Okay. Now, first try to write the equation. Before the equation, I think it is better to write the matrix. Okay. So matrix we can write easy. I1, I2. So there are two ports. Okay. Let's say that this one is V1, this one is V2, and this current is I1, this current is I2. Okay. So V1, V2 is equal to I1, I2. So there should be four parameters, 2 by 2 matrix. So this will be 1, 2, sorry, 1, 1, Z1, 2, Z2, 1, Z2, 2. Okay. So this is the matrix parameter. Okay. Now, 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 I can write the equation. V1 is equal to, so I'm considering this column first. So this one, so this matrix I have to consider. So it will Z12, Z12, sorry, Z11, I1 plus Z12, I2. This is one equation. And V2 you can write as Z21, I1 plus Z22, I2. Okay. So this is one equation and this is another equation. Okay. Now you need to find this one, Z1. Okay. This is not a mathematical question. Make a mathematical question and make a circuit. This is a circuit. Okay. So these are some resistor value. Okay. If you are given a resistors value, if you have connected the resistor value like this is a circuit, no? Huh? This is a circuit. Actually, this is a voltage divider circuit. Okay, this is a voltage divider circuit. Okay. Uh, so, uh, so always you no need to do mathematical things here. Okay. So you can use circuit related techniques. Okay. That means, for example, so you need to find Z11 first. Let's say that you need to find Z11 this one. Okay. So what happened if we remove this one? If we remove this one, then you can easily find Z11. No? If we can remove this term, you can easily find Z11. Then think a way to cancel this one. To cancel this one, okay, to cancel this one, two things possible. You can make this value 0 or you can make this value 0. So practically, consider practically what we can do. අන්තිමට තේරෙනවද මම කියපේ? දැන් මෙතන equation එකක් තියෙනවා. Yes, very good. Okay. Okay. So that is actually no, it is let's see. Yes, yes. Okay, I think that. Okay, you're correct. Okay. So actually, if we need to get rid of this one, what you have to do? Okay, what you have to do? This Z12 is not, we can't say it is 0 or 1, 0 or value because we have to find it. Okay? But we can make this I2 0. How to make this I2 0? How to make this I2 0? I2 is the current here, from here. If you want to make this I2 0, what you need to do? You no need to do nothing. Okay. Yes, Z infinity. You need to make this Z infinity. For that one, you need to keep it open. You need no need to do anything. You need to keep it open. Then there is no I2 current. Okay. If you keep this port open, there is no current. Okay. Then you can apply a known voltage here. Known voltage here. And you can measure the current. Then you can measure V1 and I1. Then you can easily find the value here. Okay, so you can connect a battery for example 2 volt. Then you can fix a meter here. Then you can calculate the I1 also. Then V1 divided by I1, that will be the Z1. Okay, so likewise you can practically generate it, practically calculate it. But here actually that means you need to do this I2 0. Okay. Then Z11 will be V1 divided by I1 when I2 is 0. Okay. This Z11 is equal to V1 divided I1 only Z2 is equal to 0. Okay. So actually these are not correct. These are not 100% correct. Okay. Actually, there is a condition. In this time, the I2 should be 0. In this time, I1 should be 0. In this time, again, I1 should be 0. In this time, I2 should be 0. If this I1, I2 was 0, these equations are valid. Otherwise, these are not valid. Okay. So we have to write this condition also. When I am doing this, okay, I didn't mention it, okay? But actually you have to mention that one. But otherwise, it will be a mistake. It will be wrong. Okay. So, okay. So here you can see that when you are defining Z11, the condition is there. When you define Z12, the condition is there. Okay. Z22, the condition is there. Okay. So you need to mention this condition also. Otherwise, that equation not be valid. Okay. Okay. Now you can make this I2 0. You can make this I2 0 by keep this open. Okay. Then if you keep open this, okay. Now you have only this circuits, no? You have a resistor here. You have a resistor here. Okay. Now this is open. Okay. No current is flowing. Okay. So this part is not affected to this circuits, no? Okay. So if you consider this part of circuits, actually you no need to give voltage and measure current. Okay. Directly you can tell the resistance in this circuit. What is that? Z, yeah, that is ZA plus ZT. That means actually these are uh, serially connected impedances. Okay, so Z11 will be ZA plus Z. Okay, so in the same manner, try to find other parameters. Other parameters also. Z11, Z12, Z13, likewise. Okay. And so as a homework, try to do that one demand. Then and also there are some questions. Okay. So I will give some questions here also. Actually, to your final paper also, I'm normally choosing question from this section. Okay. From this problem section and give. Okay. Okay. So do that question, okay, and also try to do this one also. Try to do this question also. This one. Derive Z and is try to find Z and Y matrix for this question. Okay. For this one and this one. Okay. So as a homework, try to do that one. Okay. So maybe tomorrow we can discuss. If you have times after 12 o'clock, you can come and meet me and we can discuss this example. Okay. So try to do this as a homework. Okay. So uh, is that okay, Randima? Do you have any problem? Okay. So if you don't have any question, shall we wind up the session? Uh, that is uh, actually that is a LC circuit. Okay. Maybe that is not discussed in your basic one. No, that is actually LC circuit. It is just a inductor and capacitor. Okay. Mm, So maybe you haven't come across this. Maybe that is okay. Yeah. Okay. Thank you. Actually, we need to mark the attendance. Okay. So thank you. Give me a moment.